So today we are going to learn what is the conical pendulum. So first of all, let us understand what is the pendulum. So see here, suppose this is the point object. Normally this point object is said to be a bob. You can call it as a bob. Okay. And this bob is connected to a long, flexible, long, flexible, massless, inextensible string. So this bob is connected to this string and both are suspended from a rigid support. So this is the rigid support. Rigid means rigid body. So that body will not deform after the application of external force. Suppose this is the body, and if I am applying an external force on this body, then there will be no any kind of deformation. It means that there is no any change in the shape and size of the body. Then such a bodies are said to be a rigid body. It means that whatever be the force is acted by the bob and the string over the rigid support, so it will not affect. Okay. Now see very carefully. If you are applying an external force on this bob, what will happen? This bob will oscillate in a vertical plane only, isn't it? If you are applying an external force on this bob, then this bob will move in this direction. And therefore, such a pendulum are said to be a simple pendulum. You can call it as a simple pendulum. But here we are interested to understand what is the conical pendulum. So for that, what will happen now? See here. The string, this string can revolve along the surface of right circular cone. It means that this bob will perform horizontal circular motion like this. It means that this string is revolving along the surface of right circular cone. You can consider this is the string and bob is present over here. See here, this is the rigid support, this is the string and bob is connected here. If you are applying an external force, then this bob will perform the horizontal circular motion. Okay, and this string will revolve around the right circular cone. So this bob is performing horizontal circular motion. This is the important. Now imagine that the bob is present here. Okay, and this is the radius of the horizontal circle, isn't it? You can say this is the point A, this one is the point B, and this is the point C. Now this is string making an angle of theta with the vertical axis. Okay, so this is what? This is the length of the string. So this string making an angle of theta with the vertical axis. So as you know that both are perpendicular to each other. Therefore, ABC will be a right angle triangle. Okay, and AB is the height of the string. Is it clear to all of you? Now at point C, now just imagine that for equilibrium position, for position B, okay, sorry, for position C, not B, for a position C. Now the condition is that the bob should be in equilibrium position. It means that whatever be the forces are acting on this bob at the point C will null each other. All the forces acting on the bob will cancel each other. So first thing is that which forces are acting on the bob. Okay, the forces. So first of all, if we will see here, the forces acting on the bob are. So first force is its own weight, isn't it? This bob is having a some weight. Weight is a one type of force which is always acting in downward direction. Okay, so first force is its weight, that is mg acting vertically in downward direction. This is the first force. Now second force. Now already you know that this string is in tension, isn't it? Therefore, the force tension T is acting along the string. So therefore, second force is force T due to tension in the string. Okay, and that is acting towards the center O or towards the center A. You can call this point is as a O, or we can call it as this tension will acting in upward direction. So see here, this tension is nothing but what? This is the inclined force, isn't it? This is the inclined force. And for equilibrium position of this bob, we need to resolve this tension into two components. That is the horizontal component and vertical component. So by geometry, we can say that if this angle is theta, then the alternate angle will be also theta, right? So this angle will be theta. So we need to resolve this tension into two components. So always remember that the angle theta with respect to the axis is always cosine. It means that we will represent this vertical component as a t cos theta, and the second axis it will represent as a t sin theta. जिसके साथ थीटा होता है इसे हमेशा कोसाइन लेना है, और जो सेकंड एक्सिस होगा इसे हमेशा साइन लेना है. सो ऑलवेज रिमेंबर दिस वन. ओके, सो इट इज नथिंग बट व्हाट? t cos theta. So here we can say this is the t cos theta, and second will be t sin theta. Now this bob is performing a horizontal circular motion. It means that there is a presence of centripetal force, because without centripetal force we cannot perform a circular motion. And exactly opposite to that, which force is acting? That is centrifugal force, which is acting away from the center of the circle. So we can say that the force which is acting, that is centripetal force, and centripetal force is m r omega square. So these all the forces are acting on this bob. And if you want the equilibrium position of this bob, it means that the weight of the bob is balanced by t cos theta. And the centripetal force of this bob is balanced by t sin theta. तो ये सारे फोर्सेस एक दूसरे को कैंसल कर रहे हैं, तभी जाकर ये जो ऑब्जेक्ट होगा ये इक्विलिब्रियम पोजीशन में होगा. सो फ्रॉम फिगर वी कैन से दैट व्हाट वी कैन राइट हियर, we can write here t sin theta. So see here, we can write here from figure t sin theta is equals to mr omega square. Say it as equation number 1. And second force is t cos theta. So t cos theta is balanced by its weight, that is mg. Say it as equation number 2. So both forces are equal in magnitude but opposite in direction. Okay. So divide equation 1 by equation 2. What we will get here? T sin theta divided by t cos theta is equals to mr omega square divided by ng. See here, we have to find out the time period. What we have to find out here? We have to find out the time period of this bob to perform the circular motion, or we can say to perform the one revolution. So what will be the time period? So we have to find out the formula. So T will get cancelled, and you know that sin theta upon cos theta is tan theta is equals to m will get cancelled, r omega square upon g. Okay. Therefore, we can write here omega square is equals to g into tan theta divided by r. Okay. Now see the right angle triangle ABC. What will be the sin theta? Yes, sin theta is opposite side divided by hypotenuse. Therefore, we can write here sin theta is equal to, what is opposite side? This is the r. What is the hypotenuse? That is the L, length of the string. And therefore, we can write here r is equal to L sin theta. So, r is equals to L sin theta. So, just put this value r in the given equation. So, we can write here omega square is equals to g into tan theta divided by. So, instead of this r, I can write L sin theta. Okay. So, omega square is equals to g upon L into tan theta means what? Sin theta upon cos theta into sin theta. So, 1 upon sin theta. So, sin theta will get cancelled, and we will get omega square is equals to g upon L into 1 upon cos theta. Okay. So, what will be omega? Omega is, तो square जो है वो हटा देना है. So, we will get here under root of, yes, g upon L cos theta. So, this is the angular frequency, but our aim is to find out the time period. So, for that, we know that omega is nothing but what? Omega is 2 pi upon t. And here, t is equals to time period. So, t is equals to 2 pi upon omega. Now, just put this value of omega in this equation. So, here we will get t is equals to 2 pi upon under root of g upon L cos theta. So, we can say that 2 pi into under root of L cos theta upon g. And this is the equation for time period.